My name is Eirik. I come from Norway as well as the last one standing here. So I work in mathematics section, and we did a study about the solution strategies for teachers in subtraction and addition tasks. This is basic. This is common knowledge. It's basic knowledge for everyone. So we wanted to find out how did they actually use, which strategies did they use in order to solve a different kind of tasks.
Technical glitch. Final. Yeah, there you go. It is. Thank you.
So we teach the students about didactics, of course, and how mathematical knowledge is crucial for them. So we have a focus on specialized content knowledge in mathematics, which involves how we explain tasks, how we explain problems, how we can represent it in different ways, and how we can visualize solutions to smaller children. This is first and second grade students in primary school. In order to do this as a teacher, we need the flexibility using multiple strategies, and we also need the adaptivity to choose an appropriate strategy. Well, some strategies could be more harder to solve with basic illustrations than other tasks could be. So we thought that the pre-service students often rely on algorithms. When we also had little variation in the strategies, and we could see that they had some problems with negative numbers and mathematical representations to solve tasks in different ways. So that brought us to the research question: which solution strategies do they use? And the framework we used is the PRO about the mathematical content for teaching, knowledge for teaching, and the specialized content knowledge about explaining, representing, and varying solutions if you want to be a teacher, you need these abilities. And Higginboth also gives us kind of a language for how we can group the different strategies that the students used. So Higginboth, we measured it in different types of strategies, sequential strategies. There's a number line. This is actually a part of the Norwegian curriculum, and decomposition, that we are dismantling the numbers into different smaller parts, and varying, that will compensate if we borrow, if we're missing an amount, we can just round up a number, and we can have this numbers that we turns into tens and ones and hundreds and so on, different. And we have the standard algorithm that we all use. That's addition is quite a basic knowledge for all of us. But it's mentioned as point in the Norwegian curriculum for first and second graders. So to understand the use of number line, we need the magnitude, the relationships between amounts, and we need also knowledge about negative numbers. So what we did in our study is that we asked 22 pre-service teachers for the first semester how they would solve these different tasks, and if they could describe their solution methods and how they would find out how they would describe how they solve the tasks. And we did a Higginboth framework in order to. So some example for the tasks. You can see that this is it's not very complicated, but you need to think and you need to have your words correctly if you want to solve them. And we have some focus on negative numbers and unknown values as well. So the main findings have some. The main findings is that we have a strong dominance of main algorithm-based strategies, and we have a limited use of number-based strategies, as I was talking about earlier on. And then number line was also almost absent in our research, in our results. So then this is a table of how we measured it. We have these different types of how to solve the tasks. The sequential strategies were almost none, and we can also see that the variation of strategies was also absent. If they used one strategy, they follow through with the same strategy. That's the variation. And as well as we talked about earlier on, the specialized content knowledge, that we need flexibility and adaptability in order to solve tasks in ways that are more natural, actually are easier to explain, easier to write, and to find a solution. So findings is at the number line, even though it's in the Norwegian curriculum at first and second grade, it's almost never used. Especially even in tasks where it would be easier it would be beneficial to use alternative strategy than using a column-based method to solve the equation, to solve the task. And it's not a part of the student's natural thinking. This is quite a new part of the Norwegian curriculum that number line should be implemented in first and second grade. So they are not trained. It seems like most of the students are using the strategy and algorithms that they've learned earlier on in life. And even some tasks in negative numbers, there was high rate of non-response. They weren't able to explain how to solve it. They could do it mechanically with an algorithm, but to explain it and to draw it and to find, one line go backwards, to go forwards, it seems hard for them. This indicates a conceptual difficulty for the students. That this as addition is a basic mathematical concept, and it needs to be taught in first and second grade. But it seems like they have this struggle even explaining how to solve the most basic tasks when they need to represent it in different ways. They are encouraged to do that in different types of ways. So it's a strong procedure knowledge and weak conceptual understanding for such a basic problem. So that's what we have been talking about in instrumental versus relational understanding. And the things we see is that we need to strengthen the representational competence, that they are able to solve tasks in different ways, use solution strategies based on the task they are presented, but some strategies could be beneficial for some different types of tasks, etc., etc. And the diversity of strategies, and that we should have been used in number line more in order to show, to explain for children how to solve tasks. So what should be developed? Flexibility, multiple strategies, like the four I mentioned early on. The adaptivity, to not choosing one and sticking with one strategy, that you use different types of strategy based on the tasks, as I said, and the conceptual understanding. Even with negative numbers, we need a broader conceptual understanding, subtraction tasks. So algorithm dominance is our conclusion, low flexibility, and the use of the number line that should be more represented in as part of, especially the Norwegian curriculum. And we need to strengthen the special content knowledge earlier on in teacher education. So, yeah. And for future research, we should have a test that actually tests students in the beginning of the research to teachers to the study program, and in the end they are done with. But this is basic knowledge that they should be able to, also, even if it's first semester, they should be able to represent in different ways. Some did, of course, but as you see, 60 to 70% of the students just use the standard algorithm. And we should look at development of it. That's fine.
Thank you very much.